Welcome back. A little change of plan on the video series. We were going to work on the rails for the Mogul skid, but I had an opportunity to make the pattern for the piston that I need to cast for this engine. So this video is going to be the process as best as I could document it, and then a discussion of that core box pattern process. So enjoy the video. All right, let's look at the pattern for making this 8-horse Mogul piston. We have two parts here. One here is the part that makes the outside diameter of the piston. If we just used this by itself, it would make a solid piece of cast iron. It would be solid all the way through, and that's not what we want. We want this internal part here to be open, void of cast iron. So we have to make this part, which is a core box, and it makes this piece in here out of sand that the foundry will set in the mold, and with the void that this part makes and the fill-in that this part makes, you'll cast a piston that is hollow. So let's look at a piston here. This is a much smaller piston. It's out of a 3-horse Edwards engine, but it's the same sort of deal. All pistons are kind of the same. They have a cylindrical shape, and they have a cavity inside that's hollow. The piston is not solid. So that's what we have to do here with this core box. So let's go over the pattern itself first. I'll set this out of the way. And we look at this pattern. It's a split pattern because it comes apart. And the foundry will put each one of these in a mold just like this. They'll pack sand around it, and then they'll pull this out, and there'll be a void there where this part was. It's very important that all surfaces on here have what's called a draft, which allows the part to come out without ripping the sand out. If you've ever seen a casting that looks like it has a little iceberg sticking off of it, and it's rough and it's bumpy and not uniform with the rest of the part, then what's happened is part of the sand has fell out in the process, probably of removing the pattern itself, or just in the shock process of the cast iron, molten cast iron running in there, and it'll leave a void and make a rough part. So these ends are drafted. That's the term, draft, 1 degree, so that they set like this in there, and when you pull that out, it pulls straight out and releases from the sand, and it does not drag against the sand. Very important. Foundries won't be too happy with you if you make a pattern that doesn't have draft on it. They won't like that, and they'll charge you to fix that. With this pattern, I've got about 16 hours in it so far. So pattern making takes a while, and it's expensive. You multiply that by a shop rate in a foundry, and you've turned your part into several $100s just making the pattern. So any of this stuff that you can do yourself and do correctly will save you money. Nobody benefits from a poorly made or incorrectly made pattern. So this is a split pattern. I made it by laminating boards with wood glue, clamping them, and in the middle, right in the middle, I put a piece of paper. It was actually an office folder like you have in your filing cabinet, and I put that in here, glued it in here, and then stacked the rest of the boards up right in the middle. And then I formed the basic shape that you saw at the start of the machining video when I used a metal lathe as a wood lathe. I shaped that with a hand power planer to get it somewhat round because it was totally square. And then when it was turned to dimension, then I just stuck a wood chisel in along this plane and popped the two pieces apart, and they came apart beautifully. So that's how you get it. I mean, if you have a big bandsaw, you can just cut it, but that's one way of getting a very nice break in the wood there, and not having to fight the glue. So this pattern, this is actually how big the piston will be, and it is 6.5 inches in diameter. My piston is 6 inches. And why am I going to the expense of casting more than I need, and it's going to be heavy, and I got to machine all of it off? Well, the problem is that outer crust on a piece of cast iron is very hard. It's very inconsistent. It's got sand in it. It's just not good homogeneous material. So you want to machine down through that. So by going 6.5, I've got 1/4 inch on each side, all the way around, of this piston that I can machine off, and then I should be in homogeneous material. So that's why I did that. Plus, you also have to account for some shrinkage. Cast iron shrinks 1/8 of an inch per foot, so I would expect about a 1/16 of an inch shrink in this direction. So I got to accommodate for that, or I'm going to get a beautiful part that is too small. Also, the part is going to be 1/2 inch longer than it needs to be for the same reasons, because of shrinkage and just getting into homogeneous material. One thing that this pattern is not going to do is it's not going to have this radius or this angle on here on the head of the piston. It's going to be just square, just like this, and I'm just going to machine that down. So not a huge deal. It's just easier to make it this way. So this is actually how big the piston is going to be. But this part here is a very, very important part. It will make a void in the sand, and then that will be where the core sets in and hangs out over here. So this is the anchor for the core. So this piece has to be a little longer than the sand piece that's made in the core box, so that it sets in here. You don't want them to be exactly the same size, or they can't get it in there, and they'll end up having to break sand out and have problems. It's very important that this piece be big enough to hold this part and also handle any forces of buoyancy that happens during the pour process, because that cast iron is going to run in there like water, and it's going to try to do what they call float the core. If it floats the core will move up, and then you're going to get a bad part, because then this diameter here, this inside piece, will be shifted off and maybe clear through the part. So if that's the case, then it's a bad part. So you want to make sure that this anchor here, this piece back here, is adequate size to handle that forces that you think you're going to have on that part. The mold, the pattern itself needs to be built tough enough to handle the fact that they are going to use a pneumatic packer to pack this sand in here. So it can't be real delicate. It's got to be, you know, I put wood screws in here. I've got Bondo holding these parts together. It needs to be tough enough to handle that. It also needs to be tough enough to handle the shipping process, because I've got to send this to the foundry. Now, this is the side that's going to make the piston profile. So you try to smooth this as much as possible, again, to keep the sand from sticking to it. You don't want to paint it. You don't want to varnish it, because the sand will stick to that and it'll pull out and make a rough part. So I've got some more sanding to do here, because it's easier to get rid of these imperfections in Bondo and wood than it is to get rid of them in cast iron, even though I'm going to machine down through it. This side, same sort of deal. It's got to be smooth, and just the more work you do on the prep of the fixture, the pattern, the better off you'll be. So that is the part that makes the piston slug, and if you only had this, it would just cast a solid piece of cast iron. Not anything too wonderful about that. I have draft on each one of these ends so that the part can be pulled out. So what they're going to do is they're going to use this first in the mold, and then they're going to take the core box and they're going to make the core. So let's talk about that now. This is the core box. It's just a wooden box. It's filled with epoxy. It's quite heavy. It's got half of my piston that I cut in half in here. This is exactly half of the piston diameter. So this is exactly 3 inches tall. That's very important. It needs to be the size of the core that you want, because they are going to take this, they're going to fill this with epoxy and sand, let it set up, they're going to pull it out, and then they're going to do it again, and they're going to have 2 pieces, and they'll put those 2 pieces together to make a round piece. Here is the void that will be the anchor. This is what will go into the sand and hold this piece in space so that the cast iron can run around it in the void that's in the mold. We also drafted and smoothed this bore here. This is for the wrist pin. You do that so that you don't have to machine that out solid. If this was solid, it would actually shrink more. So anytime you can take material out like that, when you have a big hole like that, take most of it out, you're going to save time in machining, and you're also going to save any shrinkage buildup. So that's the core box. It simply makes the piece that goes inside the mold. That is where you do not want cast iron. So let's talk a little bit about the cast iron itself. I have a choice on types of cast iron. I can use gray cast or ductile cast iron. The difference is gray cast, the structure of the carbon is like flakes in there. So it's very brittle. It does not bend. If it tries to bend, it will break. Ductile cast iron, the carbon is spherical in shape when you look at the structure, and it can bend and flex a little bit. So it is stronger in that regard, so that it can take some flexing. It tends to be more expensive and isn't always necessary. This piston, I'm just going to make it out of gray cast for 2 reasons. One, I don't need the extra strength of the ductile. For a piston, it's not going to need it. Also, the gray cast that is done today is quite a bit better than back when this engine was originally built. Back then, this cast iron was about 25,000 pound burst rated for strength. Now, your base gray cast is about 65,000 pounds. And the ductiles go from 85 to 100,000. So I'm just going to make it out of gray cast. Plus the foundry that I'm sending it to only does gray cast anyway. So that's a decision you have to make. For some parts, if they're real long and skinny, if I have to recast those, I will make them out of ductile. Here's an example of a part that I would make out of ductile. If I had to recast this part, I would make it out of ductile. This is a rocker arm for that 8-horse Mogul engine. It's quite long, it's quite spindly. They do break from time to time just because the castings were not good back then. If I had to remake this part, I would make it out of ductile just because I have the technology today available to make the part stronger. And I know that it was a weak, problematic part. So, okay, so you got your pattern all done and you're ready to send it off to the foundry. Package it well. There's a couple of ways you can do that. You can make a box or find a box that's only big enough for this pattern and send that, and then say in the box, tell them to return the pattern in that box. So that will keep the parts that they make from being crammed in the box with your pattern, and you get it back and stuff's broke up and dented up and stuff. So that's one way of doing it. The other way is to send a box that's big enough to accommodate the parts that you're making, and that's what I'm doing. So I'm actually going to send a crate because this castings, I'm making 3 pistons from this pattern, so I'm going to have the pattern weight plus 3 pistons. So it's going to be quite heavy, and I'm going to make a crate to put all that in, and hopefully when the shipping company plays flag football with it, it won't get broke up. So be sure to package it correctly. Be sure to put your name and a phone number or something on each piece of the pattern. Identify this as the core for this pattern. Just give them some instructions because they don't know what you're doing. And also put in there a note of how many you want and if you want gray cast or ductile. And then also they will call you if you tell them to and give you a price on what the part is going to cost. That doesn't include shipping, so keep that in mind. I really hope that I can make these pistons and get them sent back to me and have them sitting here in the shop for $150 to $200 each. So there are no $5 casting parts. Casting parts is an expensive thing. It's hard to do, takes a lot of energy and time, and there aren't any foundries close to me, so I have to ship stuff. So it just, it's expensive. So know that when you're getting into this, you're going to spend some money on it, and it's not that they're gouging you, it's just an expensive process. So again, just some key points about all this. Smooth up your parts. Your part prep will save you money because the foundry will not have to do it. A good pattern will save you money. Having some knowledge about that pattern making will save you some money. And also understand what the different parts do. This is a very simple core box. It's actually a pretty simple part that demonstrates a core box principle. So, I mean, you can get very complex parts, very complex patterns. I am by no means an expert on patterns. I do pattern up my own parts, prep my own parts, but I am not an expert, so I'm constantly learning. This was a learning process for me. To figure out how to do a core box, basic procedures and what you can get away with and how they work. So hopefully this has been helpful for everybody, and we'll see what the pistons look like when they come back. Okay, another video in the books. Isn't that right, Ike? Another video done in the series for the 8-horse Mogul. Thanks for hanging on so long. It's a long process working on one of these engines and getting it right and getting everything done. So it's just going to be a process, and we are getting very close on the skid. We'll make the rails next time, and then it's ready to put some assembly time on it. and see how everything fits. So pretty excited about that. One couple of points here. One, that epoxy that I used, we used about a gallon of it, and it's about $90 a gallon. So you know, there's expense, you know, in the process. Just casting parts is just an expensive business. It's just the way it is. Also, if you've ever seen an old piece of a machinery that has a flywheel that has a curved spoke in it, the spokes aren't straight. Part of that was decorative, but it was really functional as well. Remember I said the cast iron would shrink, and that caused stresses in those flywheels, and it would actually break the spokes. So that curve allows that spoke to shrink and stresses to occur without stretching and breaking the spokes. So kind of an interesting fact there. So Ike got a new haircut, and he's looking pretty sharp. And he says to like and subscribe if you haven't already, and leave a comment. If you got questions, covered a lot of stuff in here. Sometimes I gloss over things just because I already know them and don't think they're an important thing. So please leave a comment, and thanks for watching.